Alright, to continue our discussion, we're going to talk about no solutions and infinite solutions. So example 5 says, is the inequality always, sometimes, or never true? So we're going to solve this like normal and see if it actually ends up being one of those three options. Alright, so first thing we got to do is get rid of the parentheses. So again, to get rid of the parentheses, we're going to distribute. So negative 3 times x gives me negative 3x. And negative 3 times positive 7 gives me negative 21. We have negative 3x plus 14 on the right side. Alright, now this one, they're both the exact same number, so we're just going to move one of them, so it's going to move to the left. So the opposite or inverse of negative 3x is positive 3x. So I'm going to add 3x to both sides, only dealing with the x's. These will zero out, and this will also zero out. So we'll be left with negative 21 is greater than positive 14. So, is this a true statement when the x's cancel out? Is negative 1 greater than 14? Instant answer to that should be no. So therefore, this is never true. All right, so look at the next one. Again, I have parentheses, so I'm going to distribute first. 4 times 2x is 8x, minus 4 times 3, which is 12. And I'm going to distribute the 8. So 8 times x is 8x. 8 times 1 is 8. Alright, so again, I'm going to move my x's to one side. Again, they're both the same. So the inverse of positive 8x is negative 8x. So I'm going to subtract 8x on both sides. They're both going to zero out once again. And now I'm left with negative 12 is less than 8. So is negative 12 less than 8? Yes. Therefore, this right here is always true. Alright, so let's move on to the next one. So and or inequalities. To solve a compound inequality containing and, find all values of the variable that make both inequalities true. Alright, so for example, if I was to have 8 less than 2x and 3x is less than or equal to 21. Alright, over here to solve for x, I'm going to divide. So that would be 8 divided by 2, which gives me 4 is less than x. And if I divide both sides over here by 3, I'll then get x is less than or equal to 7. Alright? So when it actually has the word and, it makes both statements true. Alright, so if I make a number line here, and I'm going to put let's see, so it's 4, so, alright, so I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this is going to be 0, this will be 8, so that would make this 4, and this 7. Alright, so we've learned already that at 4 doesn't have a line underneath it, so it's going to be an open circle. Now the x is on the wrong side, so remember, when the x is on the wrong side, you want to flip the entire inequality. So we're going to switch the x and the floor, so this is going to be x in floor, and then flip the inequality, so make it from less than to greater than. And you'll see that it's actually pointing to the right, so I would shade to the right. But when I come over here to 7, I see that it's an open circle, it has a line underneath it, so it has a closed circle, and it's pointing to the left. Now, for it to be, when it's an and, you're only shading what the two parts intersect. So therefore, you're only shading this part. You're not going to shade everything else. So again, when it's an and, it makes both inequalities true. And this is the only part that makes both of them true. Okay. It's different, though, when we're dealing with the or. So to solve a compound inequality containing or, we're going to find all values of the variable that make at least one of the inequalities true. So if we have something like this, 9 plus m is greater than or equal to 12, or 6 plus m is less than 2. So when I solve this, of course, I'm going to subtract 9 on both sides. That gives me m is greater than or equal to 3, or I'm going to subtract 6 now over here. M is less than negative 4. There's so again, or makes either statement true. Alright, so if I take a number line, make this 0, 1, 2, 4, make that negative 4, make that positive 4. Alright, so at 3, which will be right here, there's a line underneath it, so we'll get a closed circle, and it's pointed to the right. Over here I got negative 4, no line underneath it, so it's an open circle, and it's pointed to the left. So therefore, with an or statement, it could be either this, or it could be this. So you would actually shade both of them. So you'll see here, I like to sometimes call it, an and situation makes a sandwich. It's where they intersect. An or situation splits and makes like wings because it goes in both opposite directions. Right? So you can think of it like that if you like. Alright, example 6. Solve each inequality and we're going to graph the solution set. So when you see and or, that doesn't mean you solve this one and this one, or you solve this one or you can solve this one. You have to solve both of them. And just remember that and is the intersection. And or could be both. Right? So if we solve them separately, I'm gonna get rid of my constant first, so I'm gonna add 1. That goes away. 5 plus 1 gives me 6, less than or equal to 3x. Alright, and then I get rid of my coefficient, so I'm going to divide by 3. So I get kind of backwards, so 6 divided by 3 is 2. So remember, I want my letter to be first. I'm going to switch x and 2, put my x over here, and 2 over here, and then flip the inequality. So instead of a less than or equal to, I'm going to make it a greater than or equal to, just so that my x is on the left side. Over here, the only thing I have to do is get rid of my coefficient, which is dividing by 2. So that gives me x is less than 6. So when we write this out, let's see. Actually, let's make this 0, 1, 2, 3, 4, 5, 6. We're going to throw that 2. Because it has a line underneath it, it'll get a closed circle. And then it's pointing to the right. And then my 6, no line underneath it, has a open circle, and it is pointing to the left. Right? And because it's an and, it's where they intersect. So I'm going to shade between the two numbers. And there you go. The or, again, we're going to solve both of them. So I got to get rid of my constant first. So I'm going to do the inverse of minus 3, which is adding 3. 7w is greater than 11 plus 3, which is 14. And then get rid of my coefficient by dividing. Divide both sides by 7. And 14 divided by 7 gives me 2. Come over here again, I'm going to get rid of my constant first. So the inverse of subtracting 1 is adding 1. I'm going to write it below the number line. Gives me 4w is less than negative 13 plus 1, which is negative 12. And then I got to get rid of my coefficient by dividing. So w is less than negative 3. Okay, so if I work this out, see if we take the 0, 1, 2, 3, negative 1, negative 2, negative 3. Try to separate it there. Alright, so I got w is greater than 2, so I'm going to go to 2. There's no line underneath it, so it gets an open circle, and it's pointing to the right. Go to negative 3, it also doesn't have a line underneath it, so it gets an open circle, and it's pointed to the left. So my answer here is the shaded part of this, and the shaded part of this. So again, the or goes in opposite directions. Normally, there are situations where that won't always work. We'll see those soon. Alright, so let's look at C. So again, gotta get rid of my constant, so I'm going to do the inverse of adding 1, which is subtracting 1. So 16 minus 1 is 15, less than 5x. Then get rid of my coefficient, so I'm going to divide both sides by 5. 15 divided by 5 gives me 3. Again, the letter's on the wrong side, so I'm just going to switch my x and my 3 and flip my inequality. Come back up here, get rid of my constant, so I'm going to subtract 9 on both sides. It gives me 3x is less than negative 3. And then get rid of my coefficient by dividing. So x is less than or equal to negative 1. And so again, 0, 1, 2, 3, negative 1, negative 2, negative 3. Alright, so I go to 3. It's an open circle because there's no line underneath it. It's pointed to the right. Go to negative 1. It's an open circle because it doesn't have a line underneath it. And it's pointed to the left. So again, because it's an or, I just shade in opposite directions. Alright, so let's work on the next one. So real world inequalities. So your 9-week grades for chemistry are 68, 73, 82, and 86. What is the lowest score you can earn on the final exam and still achieve a final average of at least an 80? So first step, I gotta name my variables. So let F equal the grade on final exam. Second step, I'm going to make my inequality statement. Alright, so to find the average, I know I have to add them all up and then divide it by a certain score. So your 9-week grades are those 4 right there. What is the lowest score you can earn to achieve on a final average of 80? So I got 68 plus 73 plus 82 plus 86 plus my final test, which will be F. Right? Now, so you add up all your scores to find the average, and then you have to divide that by how many tests we took. So it's 1, 2, 3, 4, 5. That would be 5 tests. So you add them all up, divide by 5, that will give your average. And you want it to be at least in 80. So that means that number or more. So this becomes a more than sign or greater than sign, but it can be 80, but it can also be more than 80. Alright, so now in step 3, we're going to solve it. So the very first thing we'll do is go ahead and add up all these numbers. So get my handy dandy calculator out. Let's see, I'm going to do 68 plus 73 plus 82 plus 86. Hit enter and I get 309 plus f over 5 is greater than or equal to 80. So anytime we have a fraction like this, remember we talked about cross multiplying, because there's no number over here, we just have to cross multiply one direction. So the 309 plus f will just drop down, greater than or equal to 5 times 80, which gives me 400. And now I can get rid of my constant by subtracting 309 on both sides. That zeroes out, so that means f has to be greater than or equal to 91. So that's why that you would have to make on your final exam in chemistry to have an average of 8 or higher. All right, so let's write that in words then. So answer in words. So you must score 91% or more to keep an average of 80%. All right, so let's look at the last problem. So a worker is taking boxes of tile on an elevator. Each box weighs 62 pounds and a worker weighs 190 pounds. The elevator has a 3,000 pound weight limit. How many boxes of tile can the worker safely take on each trip? So one, let's identify our variables. So we're going to let B equal the number of boxes. Of tile. 2, we're going to make our statement of inequality, or for the situation. Alright, so let's see. A worker is taking boxes of tile. Each box weighs 62 pounds. So that would mean that would be 62 times B. And the worker weighs 190 pounds. That means I would have to add that when the worker is on the elevator. Okay, and then it has a maximum weight of 3,000, so it can't be more than 3,000. So we're going to say less than or equal to, because it can technically be 3,000, just can't be more. All right, so then 3, let's solve for B. Right, so what I'm going to do is I'm going to take my 62B plus 190, which is less than or equal to 3,000. And I'm going to get rid of my constant first. I'm going to subtract 190. I got 62B left. Is less than or equal to 2,810. And then I'm going to divide both sides by 62. So type that in our calculator. Again, gives us a fraction, so we do Control Enter to make it a decimal, and it says 45.3266. Right? That's what it gives. So 45.323. Something like that. Alright. So let's finish this question off. So 4, answer in words. Alright, the worker could ride the elevator safely by taking no more than how many boxes? So will we round up to 46 or round down to 45? Good, you round down. You can't exceed 3,000, so you have to round down to the nearest whole, which is 45. Because if we took 46 boxes, we would be over the maximum limit and then be in jeopardy of breaking the elevator. So you can't have more than 45 boxes of time. Alrighty. Don't forget to post in the discussion board a question or comment of something you've learned, and see you in class tomorrow. Alright.